Hello student, in the chapter metals and non-metals, today we will discuss activity series of the metals. Dear student, the activity series of the metals can be arranged. Metal in activity series of metal can arrange in the order of decreasing reactivity. In activity series, metals are arranged in the order of decreasing reactivity in the series. This series is known as the activity series of metals. Dear student, the activity series is the series in which metals are arranged according to their decreasing reactivity. It means the metals are placed above is known as more active metals. Metals which are placed below is known as less active metals. Okay. So here the first metal in the activity series, the first metal is potassium. So we say that potassium is more active than other metals, then barium, calcium, then sodium. Dear student, these four metals are very active metals, and it react vigorously, means very fast with water, and also react vigorously, means very fast with acidic solution and give hydrogen gas. Always remember, when potassium, barium, calcium and sodium react with water, it react with water vigorously and also react with acid vigorously and produce hydrogen gas. That's right. Now, below these metals are known as, we say that, very active metals. Very active metals, very active metals. Potassium, barium, calcium, sodium are very active metals who react with water vigorously and also react with acid vigorously and produce hydrogen gas. Now, magnesium, aluminum, zinc, chromium, iron. Dear student, here magnesium, aluminum, zinc, chromium and iron react slowly. They do not react vigorously. They react slowly with water. Okay, student, always remember, potassium, barium, calcium, sodium react with water vigorously, but magnesium, aluminum, zinc, chromium, iron react with water slowly, but readily with the steam of water. It normal water it reacts slowly, but with steam water it reacts readily, means fast. Okay, student. Dear student, including these metals and cadmium, cobalt and nickels, tin and lead. All these metals from magnesium to lead react with acid to give hydrogen gas, but do not react vigorously. They normally react with acid to give hydrogen gas. The metals who give vigorously hydrogen gas with acid is potassium, barium, calcium and sodium. But the metal which react with acid to give hydrogen gas is aluminium, zinc, chromium, iron, cobalt, cadmium, cobalt, nickel, tin and lead. Okay, student. Just here hydrogen is placed. Okay, so we say that the metals who give hydrogen gas react vigorously with acid, and metals who react with acid to give hydrogen gas are placed above the hydrogen non-metals. Here hydrogen is non-metal. Okay. Dear student, below the hydrogen placed copper, mercury, silver, platinum and gold. Dear student, copper, mercury, silver, platinum, gold. These metals do not react with acid to give hydrogen gas. Always remember, the metal placed below the hydrogen gas the metal which placed the below, these metals are placed below, but I am right here because no place here. Okay. Yes, friends. Always remember copper, mercury, silver, platinum, and gold placed below the hydrogen. It all of these metals do not react with acid to give hydrogen gas. Okay, students. Yes, student. Now discuss some important points related to this topic. First is, yes, student, here copper, mercury, and silver react with HNO3, that is acid. You know that copper, mercury, and silver do not react with acid, but remember that only copper, mercury, and silver react with HNO3, that is nitric acid, but do not give hydrogen gas. But do not give hydrogen gas. It react with acid, but do not give hydrogen gas. Here's a question arises here: why hydrogens being non-metals has been included in the activity series? Yes, friend. We say that this series is known as activity series of metals. Activity series of metals. But here a element place, that is hydrogen, which is not a metal. So question: why hydrogen being non-metals has been included in the activity series of metals? Yes, student. The answer is because hydrogen like metals can part with an electron, its electron, to form a positive charge or cations. Yes, student. Because the hydrogen also formed cations, positive charge ions, similar to the metals. Metal lose their electrons and forms positive ions or cations. And hydrogen behave like metals, and it also lose their electrons to form positive ions or cations. So it is the reason due to hydrogen place in the metal activity series. Okay. Yes, friend. Now discuss significance of reactivity series. Yes, friend. The first significant is the metal above the hydrogen. Always remember, the metal above the hydrogen have the greater tendency than hydrogen to give electron in their solutions. Such metal are called electropositive metals. Dear student, always remember the metal placed above the hydrogen. The metal placed above the hydrogen is known as electropositive metal. Electropositive metal. So we say that potassium is more electropositive. As a potassium, barium less electropositive, calcium less electropositive than barium. And we say that the metals are placed top of the activity series is highly electropositive, and when we go to the down of the activity series, the electropositivity of the metal decreases. Okay. Yes, student. Now metals above the hydrogen can liberate hydrogen gas when treated with the acidic solution. Yes, friend. Also remember here 2 points for the metal which is placed above the hydrogen. First point is the metals placed above the hydrogen is electropositive metals, and their electropositivity decreased on the group. Okay. And second point, the metals which is placed above the hydrogen, they give H2 gas, that is hydrogen gas, in the acidic solution. Okay, they give a hydrogen gas in acidic solution because their reactivity is greater than, their positivity is greater than hydrogen. Okay. Yes, we'll now discuss here example. Zinc metals will react with acidic solution. When we place zinc metal in acidic solution, dear student, you know that zinc is here. Zinc is placed in activity series above the hydrogen. So we say that the activity of zinc is greater than hydrogen, or electropositivity of zinc greater than hydrogen. So it releases the hydrogen gas in the acidic solution. For example, here zinc when react with sulfuric acid, it give the hydrogen gas. Okay, and here magnesium metal. That's what you observe here. Magnesium metal is here. Magnesium metal that is placed in activity series above in the activities above the hydrogen. So we say that magnesium metals are highly positive. Highly positive metals, they lose the hydrogen gas in the acidic solution. For example, here magnesium when react with the sulfuric acid, it gives hydrogen gas. Okay. Dear students, how to magnesium give hydrogen gas in acidic solution? Dear student, you know that the metals which is placed above the hydrogen is electropositive metal. We say that electropositive metal is the metals who lose their electrons, and acquire positive charge is known as electropositive metal. Here magnesium placed above the hydrogen, so we say that it is the electropositive metal. So we say it means magnesium lose their electron, like here magnesium lose their 2 electrons, okay, and acquire 2 positive charge. Dear student, and you know that acid is a solution, acid chemicals which lose their protons in previous chapter. Okay, acid always lose their protons, or also we say that acid lose H plus ion. Acid lose H plus ion. Here sulfuric acid have 2 H plus. Basicity of sulfuric acid here 2. So sulfuric acid lose their 2 H plus. When sulfuric acid in solution lose their 2 H plus, these 2 H plus gain the electrons lost by the magnesium metals, okay, and convert into hydrogen gas. This is the process of releasing hydrogen gas by the more electropositive metals than hydrogen. Okay, student. Dear student, now discuss a more electropositive metals replace a less electropositive metal from the solution of a salt of the less electropositive metal. Dear student, in previous chapter we are discussed about the single displacement reaction and double displacement reaction. In single or double displacement reaction, you say that more active metals replace the less active metals from their solution. This trend, just same things explained here. Here, say that a more electropositive metals replace a less electropositive metal from their solutions of the salt less electropositive. Dear student, how to distinguish the metal who is the high electropositive and who is the less electropositive, who is the high reactive and who is the less reactive? Dear student, the metal placed above is the more reactive than below. Like here, potassium is more reactive than barium. As compared, when we compare magnesium and zinc, so we say that magnesium is more active, more electropositive as compared to zinc. And as compared to zinc and iron, we say that iron is less electropositive, less reactive as compared to zinc. So if we use zinc in a reaction, it replaces the iron from their side. And when, for example, here we use zinc to react salt solution of copper sulfate. Okay. Yes, we will now discuss here. Yes, one copper sulfate. Here copper, and here iron. Yes, when you observe here, iron placed above the copper. So we say that the reactivity of iron as compared to copper is higher. So it replaces the copper from their salt solution. For example, iron here copper. Just so you know that the reactivity of copper, electropositivity of copper, iron is greater than copper. So iron replace the copper from their salt solution and convert into FeSO4 plus Cu. This is known as single displacement reaction. Dear student, for the solution of the questions related to single displacement and dual displacement, you use this series of the chemical reaction activity series. Okay. Dear student, I think you understand all about the activity series of the metals and their important features and significance. Okay. Let's do now in next lectures we are discuss more about this related to this topic, and I request you please solve the questions related to this topic given in NCERT book, and also relate this topic with the single displacement and dual displacement reaction. Thank you very much.